Alright, so I just want to review the quiz. This is our last quiz before the unit test, so there's just quite a few things on here that might have been confusing, although overall most of you did a really great job, just some small mistakes if there was any I saw. This first problem, these two ask about similarity, and to find angle similarity, what you need to do is actually find all the angles and then see what happens from there. So, right here, I know all triangles are 180 degrees, so I'm going to minus the 40, and I'm going to 180 minus 40 minus 120, and that gives us 20 degrees for this last one. I'm going to do the same thing here, 120, 180 minus 120 minus 20, that gives us 40. So let's see, an angle of 20, an angle of 40, an angle of 120, these are similar. Okay. We can't actually check the angles here because we don't know any of them, so instead we need to check the ratios. So let's just see here. I'm going to use these two sides here, 9 over 21, and see if those are equal to 3 over 7. There's quite a few different strategies for this, but since a lot of you are really good at the proportions, I'm going to show this strategy here. Looks like we'd have to round up to 9, and this, well, in the calculator I can already see that we would end up with exactly the same ratio. These are equal. We should check the other sides as well. So I'm not going to do that for you, but do set up the same ratio, check the other side, but you'll see once you do that, they are totally similar. Alright, let's try this problem. I think the hardest part of this problem is seeing the triangles. So I'm going to solve for x first, which is this whole length. That actually was a common error. So people try to just solve for this little part, which would actually work. You just have to add it back at the end. But let's do it how it's here. So this small triangle is 20 on the base and 12 for that slanted side. And this big triangle, we don't know that side, but we do know the 15. Okay, so let's just cross multiply here as the most common strategy I see students make that makes sense, and we're going to divide for x. X equals 25. Okay, so this goes here. Alright, now let's solve for the y. It's really tempting to think here that if what we got here, this is 5, that these are equal. And do you see how this is slightly extended, so that makes sense that this is 5 and this is 4. Alright, so this y is apart, so let's solve here. So again, let's do the small triangle first. We'll do y over 12 equals, the large side is y plus 4 over 15. 15y equals 12y plus 48. Okay, did that really quick. I distributed 12 groups of y and 12 groups of 4. So 12 times 4 is 48. Okay, now let's solve. Minus 12y from each side gives us 3y equals 48. Divide by 3, and we should get 16. Okay, so again, this first side is set up here. There's lots of different ways to set it up, but this is just one example. This side, what could be confusing is that we have the y for the small one. Here's the small triangle, y plus 4. So it seems weird that there's a y on each side, but it works out. Okay, let's move to simplifying. Remember, what's inside the radical, in a sense, will always end up with a decimal. That's why we keep it there, so we don't have rounding errors. So I have to deal with this stuff separate than this. So 70 divided by 5, I'm just going to do the two parts separately, okay, is 14. Okay, and then 20 divided by 4 is 5. That actually is the answer. Done. It's the answer because I can't simplify 5 anymore. There's no pairs in that. Okay. Alright, let's try the other side. So again, the outside we have to deal with first. So that right there is 30. And then when I multiply those here, I get 1100, so 1,100. Now I had some students leave it here, but this actually has some pairs in it. Okay, let's divide by 100 first. Okay, and we could see that's going to be 111, which makes sense. That doesn't break up anymore, and we've got 10 and 10. So there's a pair. This pair then comes out and has to deal with this here. This whole thing is being multiplied. Remember, things that are next to each other, when you write algebraic sentences, they mean multiplying. So let's multiply what's already there with this. Let me just write that out. And this part stuck inside, so our final answer is this. Okay, I can always check that decimal, so let's see here. I could go 300 square root of 11. That's what I got. And then let's just check this. 10 square root 2. Oops, sorry, this one makes me... Okay, and I'm going to multiply that by 3 square root here. And sure enough, our two decimals match. That's a really good way to check to see if you're accurate. All right. Okay, this last problem here is a simple 30, 60, 90. Let me just write that relationship on here.